As a passive house designer, I'm primarily concerned with energy balance. The essence of passive house design is the optimization of passive thermal energy flows through a building. So that's optimizing the passive gains and the passive losses, how they interact with one another across different seasons and through different climates. So there is an equation, superbly elegant equation, thanks to Dr. Feist and his colleagues at the Passive House Institute, and that is as follows. QH equals QS plus QI minus QT plus QV. Or said more simply, heat flow is passive gains minus passive losses. So, as designers, with this simple, elegant equation, we're able to understand the concept of energy balance, and then using the modeling tools, the Passive House Planning Package, which takes this equation and actually solves for it in minute detail rigorously, we can plan and develop our buildings with this simple notion in mind and solve the equation. Okay, so as an example now, gains minus losses. On the gain side, when we're designing, we're concerned about our variable QS, okay? And so our design in the building, location of the building, the shape, what sort of glazing we put, in what orientation, these sorts of variables dictate how much solar gain we're going to receive in the building across the seasons, winter, summer, etc. Okay? Other side of the gain variable is QI, internal heat gains. So we have to understand how many occupants we have in the building, whether it's a school, office building, or home, because we all generate a certain amount of heat. And then, of course, there are the appliances, the electronics, essentially anything that uses electricity creates heat. There's refrigeration equipment, etc., where there's exhaust heat off of compressors. All of these are internal heat gains, and these add to the passive gains in a building. So QS and QI, the passive gains. On the loss side, QT plus QV, QT is transmission losses. So here's where we're designing insulation levels, and we're avoiding thermal bridging in our building. And we're designing for windows and doors, what we call fenestration. Okay, what's the quality of these windows? How many are they? How big are they? Because they have certain characteristics with respect to heat flow. Okay, so this is QT, and this determines, when we put this together, what our transmission losses are passively. And finally, ventilation losses, QV, okay, this is the combination of losses through unwanted leaks in a building. We can make it tight, and in a passive house, we tighten the building we seal the building to an amazingly tight level, but there still is movement, passive movement of air through the shell. And the second part of it then is the active ventilation. Since the buildings are tight, we're constantly ventilating them using a heat recovery ventilator normally, but there are heat flows. So our wonderful equation here of passive gains minus passive losses that we solve for gives us this sort of intellectual framework and understanding where we can guide our design to begin with, and then use the Passive House Planning Package, the modeling tools, to solve for the equation and therefore minimize the amount of active energy we need to input into the building for either heating or cooling.